Yes, good evening. Yeah, my name is Jojo Kwaro, and I'd like us to look at cement manufacturing. The ordinary cement that is used in the construction nowadays. How is it manufactured? How do we come up with that powder called cement? What process does it go through to be called cement? Like, what is the process behind it? So they want us to look at cement manufacturing, and it all starts at the quarry. You know, it all starts at the quarry, where the raw materials like limestone and clay are extracted from the quarry by blasting. They're extracted from the quarry by blasting. The rocks extracted from the quarry are crushed into small pieces below 80 millimeters. They're crushed into very small pieces below 80 millimeters, and routed to the nearby cement plant on a conveyor belt. Uh, After the rocks have been quarried from the quarry, they are crushed into very small particles, say 80 millimeters and below. So, and then routed to the nearby cement plant. So they're routed to the nearby cement plant on a conveyor belt. The crushed raw material is then stockpiled in clay blending beds in the pre-homogenized hole. Yeah, the circular stockpiling is performed by a conveyor belt, which continuously stacks circularly the material on the blending bed. This method reduces substantially the chemical fluctuations of the raw materials. Yeah. So the first process here is raw mill grinding. So the pre-homogenized raw material is then weighed, dried, and ground in order to get a very fine powder with maximum size of a few ten of microns. So some alternative materials might be added, and the fine powder obtained after the alternative material has been added, the fine powder obtained is called a raw mill. The fine powder obtained is called a raw mill. So after obtaining the raw mill, after obtaining the raw after obtaining the raw mill, we then look at the raw mill homogenization. The raw mill is transferred to the thoroughly mixed in a homogenizing silo in order to get a physical and chemical composition as consistent as possible. Yeah, the raw meal is transferred and thoroughly mixed in a homogenizing silo in order to get a physical and chemical composition as consistent as possible. The chemical composition of the mixture should be consistent all through. Yeah. So after that, we go to the preheater. The preheater. This is what happened. The blended raw meal is then heated up to 850 degrees centigrade in the preheater tower using the exhaust heat in the kiln. So the raw meal fed at the top of the preheater tower passes by gravity downwards, passes by gravity through the series of the cyclones in the tower. The hot gases from the kiln are blown against the floor thoroughly through the cyclones. So the efficiency of this process enables significant reductions in the carbon dioxide footprints in the clinker. It reduces the carbon dioxide in the clinker. So after that, there's the burning, where the preheated meal is then sintered at 1450 degrees centigrade with the flame at 2000 degrees centigrade in a rhetoric kiln, insulated with factory bricks around it. The kiln is insulated with factory bricks. Yeah, after that, the molten material is then quenched. Quenching is rapidly cooling. The molten material is then quenched or rapidly cooled. Yeah, quenching is rapidly cooling by an air stream in order to obtain the appropriate crystalline chemistry for the hydraulic properties of the clinker. You get, for the hydraulic properties of the clinker. Keyword: the hydraulic properties of the clinker. Yeah. So the clinker storage. The clinker cooled down to 100 degrees Celsius is then transported and stored in a hole which with its storage capacity of tens of thousands of tons. It's very big. So this allows the cement production to be continuous. Yeah? to be continuous, including the time the kiln is shut down for annual maintenance. Yeah, this allows the cement production to be continuous. Even when the kiln is shut down, the cement is just continuous. There's no stopping. Then after that, there's a cement grinding. The clinker is then ground with gypsum as a cement settling regulator. The additional constituents such as limestone and pozzolana or recycled slag and fly ash may be added or are added. So the composition and other properties of cement are specified in the European standards of the common cement EN or 197/1. So at the outlet, the particles go through a separator in order to obtain a very fine powder with a granular distribution targeted and consistent called cement. The powder produced is very fine. So the powder that comes out of the outlet is the cement, and then it is stored in the silos. It is stored in the silos. After it has been produced, it is stored in the silos and then packed, then transported for work or for the construction works. Yeah. So let's also look at the standard proctor test. The standard proctor test is a laboratory method of experimentally determining the optimum moisture content at which a given soil type will become the most dense and achieve its maximum dry density. You get? It's a laboratory method of experimenting and determining the optimum moisture content at which a given soil type will become the most dense and achieve its maximum dry density. Yeah, so the term proctor is in honor of Proctor, a guy, Proctor, who in 1933 showed that the dry density of a soil for a given compactive effort depends on the amount of water and the soil contains during soil compaction. So the density of the soil for a given compaction effort depends on the amount of water the soil contains during soil compaction. So in order for you to carry out this test, you must have the following materials. The following materials say the compaction rammer, mold assembly, brush, rubber mallet, trowel, wrench, a straight edge tool, and a spray bottle. You'll also need a number 4 sieve, a metal pan, and a coarse grain sample of soil. So to carry out the test, yeah. Here's the procedure of the test. You first have to record the width of the metal pan as well as the mold assembly. After that, pass enough of the prepared soil through the number 4 sieve to yield approximately 6 to 7 pounds of a negative number 4 metal material. So cover the sieve and shake to remove the unwanted large particles. Place the prepared soil in a layer, metal pan, and add water accordingly. Prepare at least 4 specimens having different water contents, and note that the water content increment should not exceed 4%. No, the water content increment in each sample should not exceed 4%. Compact the specimen in 3 layers, and after compaction, each layer should be approximately equal in thickness. Prior to compaction, place the loose soil in the mold and spread it into a layer of uniform thickness. Lightly tamp the soil until it's not fluffy or loose. Compact each layer with 25 times of blows. 25 times of our blows after you have put the soil in the mold. You tamp 25 times. Using the soil with greater moisture. Yes. Repeat the addition to fill the second layer. Apply the 25 times uniformly to obtain a uniform coverage of the specimen. Yeah. For the last time, with the soil of greater moisture content, repeat the process and fill the final layer. Following compaction of the last layer, remove the collar and the base plate from the mold. Yeah, carefully trim the compacted specimen evenly off the mold by means of a straight edge scraped across the top of the mold to form a plain, even surface on the mold. Determine and record the mass of the specimen and hold to the nearest gram. Yeah, obtain a portion by slicing the compacted specimen actually through the center and removing about 500 grams of material. Obtain the water content in accordance with the test method D2216. Plot a 100% saturation curve. Calculate the dry unit weight and water content in each compacted specimen. Plot the values and draw the compaction curve, a smooth curve, as a smooth curve through the points. Plot the dry unit weight to the nearest 0.1 balanced. Yes. Plot the dry unit weight to the nearest 0.1 balanced per feet cubed and water content to the nearest 0.1%. The graphs will help you to determine the proctor test. Thank you.